With this understanding of a basic one-pipe steam boiler system, let's take a look at some other typical steam piping systems. The system we've been using as our example is known as a one-pipe parallel flow. Here, the steam and the condensate flow in the same direction in the supply and return main. For all one-pipe parallel flow piping systems, dimension A must be sufficient to provide for the gravity return of the condensate and to help prevent the system main from flooding. The system could look like this, dropping from the main immediately into a wet return. Or like this, with a dry return that eventually drops to the wet return. This system is known as a one-pipe counterflow. The condensate flowing in the opposite direction of the steam. This system requires the main to be pitched upwards, away from the boiler, at least 1 inch per 10 feet, or twice the pitch of the one-pipe parallel flow system. Since the main in a one-pipe counterflow system handles both steam and condensate flowing in opposite directions, the main pipe size must be larger as compared to a one-pipe parallel flow system. Two-pipe systems have the steam and condensate carried in separate lines. The steam flows to the radiator via the main and branches. The condensate is then carried back to the boiler by a separate return line. Two-pipe systems use traps at the end of the radiator and supply main to prevent steam from entering the return piping. A thermostatic trap at the end of the radiator discharges air and condensate from the radiator. Therefore, an air vent would not be used for this type of system. Since some condensate does form in the steam supply main, the need to remove this condensate is important to allow the efficient flow of steam through the system. Since thermostatic traps normally wait for the condensate to cool slightly before opening, a float and thermostatic F&T trap is installed at the end of the supply main, at its connection to the dry return. F&T traps are fast-acting traps that allow both air and condensate to be discharged from the system main. Modern steam boilers are designed to be much more energy efficient than older boilers that you might find on a service or installation call. These new boilers are usually smaller, maybe only a third the size of older units. Thus, the newer units hold less water. These newer boilers are designed to steam at full capacity for 10 to 15 minutes before the low water cutoff shuts them off. Many steam systems are able to return the condensate to the boiler during this 10 to 15 minute cycle time. However, some steam systems, because of building size and shape, sagging pipes, or sludge in the piping, may require 30 minutes or more for the condensate to return. For residential systems, if the condensate return is too slow, this may cause a low water cutoff to cycle off too quickly due to insufficient water being returned to the boiler. Now, this most likely means there's a problem, such as an obstruction somewhere within the system piping. It's recommended that you check the system and correct the problem. It is never a good idea to use a water feeder to increase steaming time. On these installations, fresh makeup water is introduced into the system every time the water feeder is activated. The accumulation of this makeup water will gradually flood the boiler and require frequent manual draining of the boiler to restore the proper water level. On some installations, a reservoir pipe may be used. The reservoir pipe, located here, provides additional water for the boiler. That will increase steaming time before the water level drops in the boiler to activate the low water cutoff to shut off the boiler. A reservoir pipe may be all that is needed to increase the steaming time for proper boiler operation. Consult manufacturer's instructions for proper reservoir pipe sizing and placement. On some semi-commercial installations, the use of a boiler with a condensate tank, feed pump, and a low water cutoff and pump control might be used. The receiver tank consists of a reservoir with a vent line, water sealed and open to the atmosphere, into which the return line discharges its condensate. When the low water cutoff cycles off on low operating water, the condensate discharges from the receiver into the boiler until the low water cutoff is satisfied that it has a safe boiler water operating level. The addition of a mechanical condensate return system can be rather expensive and not generally used for a typical residential steam boiler installation. During the last few minutes, we examined a basic one-pipe steam system, its components, plus examples of other common steam systems. Let's take a break now and review this material in your workbook. Remember, if there's any material you aren't sure of, just rewind the videotape and review the section again. Turn the videotape off now and complete section E in your workbook.